Let's see, this is Drake's Lounge Australia. It is the January 27th in the US, but the 28th in Melbourne. Here's what we got going on this month or the next couple of months. We got the SARA Western Conference, which will be 17th to 18th March. It's going to be at Owens Valley Radio Observatory, which is in Bishop, California. And you guys can sign up. Go to our SARA website. You can sign up for that. I think $15 to be a Zoom, to do the Zoom on that. It's a 2-day thing, and so we're going to have a fun time trying to do a sort of a hybrid Zoom and live sessions there. Also, if you do have a paper, I think we can still accept a couple papers. Let's see, our tops radio telescope observing parties are on the 1st of the month. And that's 1400 Eastern time. Then there's Drake's Lounge, which is the 3rd of the month, 3rd Sunday of the month, also at 1400 Eastern. SARA YouTube channels. What I'll do is, while you guys are talking, I'll go ahead and put the link to the SARA YouTube channels. We've got all sorts of data on the Radio Joe, Super SID, hydrogen, all the different big antennas, all the FRB stuff that Wolfgang's been doing, lots of guys doing pulsars and all the hydrogen measurements, a bunch of maser guys. So we got a bunch of stuff on those YouTube channels. Hopefully we're trying to document what everybody's doing, and you guys can just have fun. There's about 70 or 80 videos, so you guys can spend a lot of time catching up on your technology. We do also have a journal, which is which is published once every 2 months. And if you want to get the journal, you can either go to the SARA store and pay for the journals, or you can just be a member. Go join SARA, and then you get the journal for free. A couple other things going on. Also at the SARA store, which is at the SARA website, we do sell the itty bitty telescope, Radio Jove 2.0, the Super SID, and the scope in the box, which is a hydrogen, small hydrogen radio telescope, which fit perfectly with Roger, with your antenna there. All the journals and proceedings, shirts, etc. Let's see. The other thing that is going on is on February 3rd, 1930 UTC. We're sort of co-affiliation radio astronomy group led by Paul Hearn, and he's going to have a briefing by Dr. Ziri Youngby, imaging a black hole with radio astronomy. And this is a Stephen Hawking's fellow at the University College of London. So if you go to the website and you go to the forum, you can see the announcement for that. And what Paul would say is just email him, and he'll send you the link to the Zoom video. Other things that's going on this month, the HARP, Whit Reeve, who is actually a board member of HARP in Alaska, they had an asteroid experiment where they basically bounced signals, HF signals, off an asteroid, and then they got all the ham radio people trying to receive that and send them the recordings of that. So he's actually going to brief the results of that at the Western Conference on March 17th. Ted Klein, who is one of our software gurus in the organization, has produced an EZRA, as Ezra, or Easy Radio Astronomy software, which basically is probably the next advancement to the scope in the box software, which actually will collect all the data, provide you a nice control screen, and then it'll plot all the data in every kind of format you can think of. Last but not least is one of our members, Job, is been looking at masers, and he's been able to plot the W3 OH line of a maser with a small dish. I think, Roger, about the size of your dish you got. He's doing it at 1665.405 megahertz. So that's sort of the next stages of what we can do with those small dishes. And we just got Paul came online, sort of the co-host of this group. Hi, Paul. Are you there? He'll be on in a minute.
Yeah, I'll join you in a minute. I'm just busy at the moment.
No problem, Paul. Just go over some stuff.
Yeah, looks like you've got a good number. I'll be with you shortly.
Okay. Let's see. And I don't know, we got Alex online. With Alex has also something in the forum about his hydrogen drift scan projects. And so anyway, let's do some quick brief introductions, since a lot of the US group don't know the Australian group. First, Rich Russell. I'm the president of SARA right now, and my experience is from doing ham radio and originally doing AMSAT for the universities, and then branching off into emergency radio, and then branching off from there from radios to radio astronomy, which has absorbed every ounce of my retirement savings and time. So I'm having fun with it. So let's see, Roger, give a quick intro to you.
Yeah, hi everyone, Roger Heap. I live in Rylstone in New South Wales, which is pretty well in the centre of the state. We call it the Central West. It's a big state, but with the Astronomical Society of New South Wales, basically got interested in that from the optical side of it. But my background is in electronics. I'm actually an electronics technician. I was trained with a company here called Telecom, basically doing electromechanical telephone exchanges. So that was back in the days when you actually had to fix things. They didn't actually fix themselves like these days. So it was pretty good grounding and all of that sort of stuff. Of course, that's all changed now. Everything's done on the internet, so that's all changed. So when that job fell apart, I then got a job as a control systems technician at my local cement plant. So I was programming PLCs and basically doing the electrical and electronics part for there. And it closed down as well. So I've had an awful lot of redundancy action in my working career. But anyway, that sort of thing happens. So say it wrote to me, astronomy sort of came to me. We have a dark sky site near us. The Astronomical Society has a 100-acre block about 50 kilometres from here. So that's how I started getting involved in the actual astronomy side of it. And then radio astronomy more or less followed on from that, because, there's one of the few technical people there. So at the moment in our organisation, the radio side is very small. So I'm actually hoping to ramp it up a bit. And as I was saying before, my problem is I don't have the feeds and the equipment and that sort of stuff. I'll show you a photo of my latest dish that I've built, but at the moment it's not much use without something to connect to it. So I guess that's basically it. So say I've got Starlink here. I'm paying money to one of your people, to Mr. Musk. And unfortunately it fades in and out a bit because my southern horizon's not that good. But anyway, hopefully you can hear me, because I can see you all okay now. Anyway, that's it. Thanks.
Thanks, Roger. Artur, SP5QA.
Okay, hello. Hi.
I hear you.
Okay. I have, it's very late in the Poland, so I'm half asleep listening to you, but nice to be there. And I only listen at last today. What are okay?
Okay. Pablo.
Hi, I'm a ham radio operator since I was 14 years old. Always interested in radio, still active, very active. I'm a retired airline pilot, citizen scientist with backyard observatory, engaged in follow-up of exoplanets for NASA, the NASA Exoplanet Watch, as well as the Harvard Smithsonian test program, Transit Exoplanet Survey Satellite. I do a follow-up on that nightly. In fact, I'm reducing some data right now that I got last night. And radio astronomy followed naturally. And I'm just a beginner with a little bit of experience, and I'm trying to learn every day.
Okay, thanks, Pablo. Charles.
Okay. Yeah, I'm a ham, of course, K4CSO, and I'm in near Winston-Salem, North Carolina, in the U.S., East Coast area, and satellite communications engineer for many years. Did radio astronomy for a living for 8 years, and retired now. Worked also in antenna range instrumentation, but mostly satellite communications design. Have a 3.7 meter dish, and am doing hydrogen line drift scans. And that's going in the background here behind me. That's pretty much it, Rich.
Okay, Alex.
Good afternoon and good morning. I'm Alex Pettit, reside in Winter Springs, Florida. I had a 30-some year career in aerospace dynamics testing. And then after that, I put together a course for the University of Central Florida on dynamics testing, lecture lab, taught that for five years. And now I'm being totally retired. Need to find things to keep myself busy. So about 2 years ago, I discovered that it was even possible to do some type of radio astronomy with small dishes. And I began with the scope in a box Wi-Fi 1 meter antenna, and spent pretty intense effort in trying to develop the system to be about as efficient as it can be. And in parallel to that, I built a 1.2 meter system for the University of Central Florida Physics Department and got it online last November. And the performance of my system and theirs is very similar. The electronics is identical, which was really nice in troubleshooting. And so there's basically, I have two systems that I configured, and they work pretty well. And I have been spending the past few weeks taking a series of drift scans, 10-hour slices through the Milky Way, and trying to develop an image from those. And that's progressing pretty well. It's the acquisition software is pretty much off the shelf, SDR, Sharp Studio, and I wrote the processing and display software in MATLAB.
All right. Hey, thanks, Alex. Andrew.
Hi, folks. Andrew Claycock here in Tasmania. I've had a long interest and association with radio astronomy and astronomy in general. I've been working as an atmospheric physicist in the Antarctic for nearly 40 years. I'm heading to retirement now, but my main interest is in low-frequency radio astronomy, solar, Jupiter, and interested in developing more efficient broadband antennas to help out the amateur community. There's some amazing innovations now with the big SKA and other low frequency projects. So interested in applying those in the amateur world. Thanks.
Thanks. Blair.
Yeah, Blair Lade, South Australia. I'm a tech, been a tech for years. I started out in seismic, ended up in rocket motors. Don't ask how. I just want to share the initial picture that the first image I got ever in my radio astronomy. I think you can see that, can you?
Yes.
Yeah. So that was the result after 2.5 years. Pretty noisy, but that's a scan. Obviously, it's using an ICOM radio with software I wrote, so you can see this is the Orion region here on the right-hand side. The left is the center of the galaxy. So, I mean, that's I was pretty happy with that I could actually see something. So yeah, I'm the lead of the group sort of the lead of the group, certainly the contact for the group in South Australia. And we still do seismology. We have an interest in solar outbursts. We run multiple Callisto receivers and have the highest number of solar outbursts in the network in the world. And I've dragged along a friend, Duncan, who will give you a short talk, I guess, or an introduction. There's only about 4 or 5 of us in the group, but we also have an interest in low frequency stuff that we're working on. That's enough, I guess.
Thanks, Blair. Is DCW, who's that?
That's Duncan Campbell-Wilson.
Hi, Duncan.
Yeah, I'm located in South Australia, about southeast of Blair. I live on a farming block. My background is 30 years in radio astronomy, and current interests are developing antennas, low noise amplifiers, and stable systems. At the present, playing with SDRs. I guess last 2 years I've been doing a lot of work monitoring the Vela pulsar, looking for glitches. I have a range of antennas, but the principal one is a 6-meter antenna, and that's basically what I've been doing. Yep, part of Blair's group for solar astronomy, and have an interest in VLF because of what Andrew published. Got interested in VLF. My professional background is in developing, running a radio astronomy observatory and building receivers and integrating it. And I guess the one I'm still in contact with professionally is a thing called Upmost, run out of the Molonglo Radio Observatory east of Canberra. As you can probably see on the back wall, there's a light echoes from 87A on the image you can see. And that was a bit of serendipity for me back in 1987, which started a 30-year journey. Anyway, I think that's enough for me.
Thanks, Duncan. Jack.
Well, hello, everyone. My name's Jack Lobengier. I've been interested in astronomy since college, and that because of also having an interest in electronics, that migrated into an interest in radio astronomy. I'm a retired control systems consultant with Honeywell, worked for them for 40 years, and been retired about the last 5 or 6. And my principal interest is in building tracking systems. I've got a 3-meter dish that's fully tracking capable, and doing the hardware and software for that. And also hydrogen line observation and starting to get a little more accurate and interested in pulsar work. But that's about it for me. And I put my email address in the chat. So.
Thanks, Jack. Kim and Kevin.
Good afternoon, morning, and evening. This is Kevin. We're located in southeastern Ontario, Canada, just near the American border. And for the last 10 years or so, we've been running a radio Jove system and a SuperSID system. And hopefully in the next year or so, we're hoping to get online a 3-meter drift scan hydrogen line system. And we're also starting to look at SDRs instead of putting together 140 different pieces on circuit boards and building the hardware the hard way. So we'll see how it goes.
All right, thanks. Preston.
I came in late. What we're doing, just introducing ourselves, or
just quick introduction of where, when, how, and why.
Okay. Well, I'm retired now, but I've been interested in radio astronomy for years. I didn't have much time to deal with it when I was working. But I started off reading Drake's book way back when, and right now I've got a 12-foot dish, and I'm monitoring signals at 1420, and saving all that data. I'm bringing up a Linux machine right now, and getting ready to try to take advantage of some of the free radio astronomy software that's out there, so I can do more with my data. So that's about where I am. I'm in the process of formatting the disk on that computer now.
Okay, hey, thanks, Preston. And Richard, you just came up.
I think I did. Hi, this is Richard, and I'm in what we sometimes refer to as RF Hell. That would be Honolulu, Hawaii. And in the past, I've had a little bit to do with the Radio Jove program. Right now, I'm reduced to just watching Zoom meetings because of the listening conditions here on the island. So nice to meet all of you.
Oh, thanks. And Pablo, how come you've got a Hawaiian shirt on and Richard doesn't? That's just my big question of the day.
How come I have a what?
A Hawaiian shirt on and Richard doesn't.
I used to fly to Hawaii all the time. So this is not a real Hawaiian shirt. This is more like Polynesian. Hawaiian shirts are more understated than this.
Oh, I'm sorry.
But I have a bunch.
Well put.
All right.
I have no excuse for why I'm not wearing a Hawaiian shirt.
All right. I get it. Yeah, I was stationed out there for 11 years on submarines. So I used to have a lot, but I don't have any more. Okay, let's see. All right, well, that's it. I think Paul dropped off. I think he's on a phone call. We'll just keep marching on. Did anybody have anything they wanted to present today? And then we can go on and have each individual person, if they want to show off some of their toys, do that. Was there something that
Ted Klein and we did a Zoom explaining every facet of his EZRA, and I recorded. I have 7 hours. Mostly 90% of that is me saying, I don't understand, please explain it to me. But I haven't had time to edit it down to something that people can watch without falling asleep. But if somebody wants the links to the private videos and want to help me edit it, basically, maybe you, Rich, you want to do that? Because Ted is on vacation, I guess. He's traveling around the U.S., so he was going to do it, but I don't know when he's going to get back.
Yeah, I'll definitely help you there. And anything to add some content to the YouTube channel. Is there anything you can sort of show us some of the results, quick excerpts from your video?
No, I don't have any excerpts. They're all up on YouTube private because I wanted Ted. I edit movies on the side, but I don't have time to do 7 hours down to maybe 40 minutes. I just don't have the time. So I asked him, hey, just look at it and tell me, hey, from 3 minutes and 50 seconds to 10 minutes, that's not important. Because he explains every facet and every aspect of EZRA with the 70 plots that it creates, in addition to the fantastic real live display, which will make the scope in a box a very useful instrument. But I just haven't had time. I'm extremely busy doing all kinds of stuff.
Okay. Did you want to show do you have your display for your system up?
No.
That's always no, you don't. Okay.
The computer is asleep right now.
Okay.
I did have a video that I posted on YouTube, I think, but no, I don't have anything live right now.
Okay. Okay. Thanks, Pablo. Roger, you were showing off before we started the meeting. You were showing off your dish, and you go ahead and reshare that and sort of explain your dish to everybody.
So that's coming through.
Yep.
So yeah, it's still work in progress at the moment. I only pegged it down yesterday, but I call it the peg down dish. Basically, as I said last time, part of the concept that I'd like to get happening is to get probably a small interferometer type system with small dishes to take somewhere that is radio quiet. So in Australia, we still do have quite a few places in the centre of our country which are still fairly radio quiet. I'm originally from South Australia, by the way, so you South Australians, I know I lived out on the West Coast for a while, so basically what it means is to get the landowners to agree to let us to go out there, and there's nothing quite like a astronomical society, worldwide astronomical society, to help you convince a landowner to let you on their property for a couple of days to do this sort of thing. So basically go down there, peek down some dishes, have the system working so they can all work together and produce data that hopefully even compare with other people at the same time on other properties. So basically try and get a large baseline of small antennas spread out across the country by amateurs is my concept. So anyway, this dish, as I say, it's a peg down. It's just got three basic pegs. The center hole in it actually folds down, and the strut that's holding it up there is it's got an over center connector on it, so you just push it up to level and then lock it down. At the moment, the dish that I'm using is an old satellite dish, 1.8 meter. Obviously needs a little bit of refurbishment, but that's next on the list. And the mount that it uses was for, as I explained this earlier, it was for a system that you set it up as an equatorial mount, because back in the old days, Australia had two satellites. Our company here called Optus had Optus D3, and the other one, I can't remember what it was called, but the schools at the time needed access to both of those satellites to get various content. So they made these mounts with basically an equatorial system and a small electric motor that just moved it from one dish to from one satellite to the other. So I've taken advantage of the fact that it's got bearings in it to give me my altitude control, and I just do the azimuth by spinning it around on the mast. Now, at the moment, this is Mark 1. It's probably going to change. All of that stuff will change. I'd like to get it motorized, all that sort of stuff. But basically, this is what I've been doing for the last couple of weeks. So I pegged this down for the first time yesterday. And at the moment, the feed on it, and I'd like to get some information from the people around the place for the feed. At the moment, it's just the guts out of a 2.4 gigahertz Wi-Fi corner antenna, which I believe is very similar to the sort of systems that the your scope in a box uses, because I have actually seen one of them. So anyway, that's the next thing. I'm going to plug it into I've got an old satellite receiver, an AM satellite receiver, to hopefully do that. And my main thing has been the Vela pulsar. So it's got a 10 hertz repetition rate, so at least you can actually pick it. And I have actually picked it up before, I'm sure, with just a smaller antenna, and you can actually hear the actual noise in the background, coming out through the noise. And it's actually something I was going to talk to you guys about. There's the word sonification seems to be popping up in all sorts of journals around the place for spotting this sort of stuff. And a lot of these sources, you can actually pick out the repetition rates and things like that actually easier than you can by trying to see it on a computer screen. But I'm not quite sure of the process of sonification. So at the moment, I'm just going to demodulate it with an AM demodulation that seems to work, because, as we all know, the demodulation works on the amplitude of the wave at any particular time, and something like a pulsar, because it changes, you can actually hear it. So yeah, that's basically it. As I say, this is the first one. I sort of have thoughts in my head of making ones that can be stackable, probably more in a square format, so the dish fits inside of a box, so you can stack them up, put them on the back of the ute, and away you go. So that's the other thing with this one, is it fits inside of my tray top utility snugly. It's not much. The couple of bits fit in two corners, and the other one fits against the other side. So basically, I can't make that mount any bigger without it not fitting in the ute. And as I say, that's my concept, is to actually get the things to move around. So that's it.
I've got a silly question. Silly question again. It says U.S. silly question. Define what a ute is. Is that a Jeep? Is it a pickup?
It's a tray top pickup, I think you would call it. Pickup. All right. So with a tray top, I've got mine's a little bit smaller. It's 2.1 meters by a pretty standard 1.8 meters wide, which I think in your language is 6 feet, or is it 8 feet high? Anyway, they do work into the feet. The 2100 would be 7 feet by what is 1.8, 6 feet, 7 feet. I don't know. Anyway, it's a standard size pickup truck, tray top vehicle.
Great.
So yeah, sorry for saying you, but anyway.
Anybody got any recommendations for Roger's helping Roger upgrade his system?
Well, when you get to me, I have some slides on some of the feeds that I developed that would be appropriate for something that size.
You want to go ahead? Okay. You want to go ahead, Alex, and
okay, let's see. Let me see if this is the. Let's see. Let's back up.
Yeah, it came up.
Okay. So this is the scope in a box, the development project that I did over the past year. And in fact, there's even an upgrade to this, and then I added some lightweight aluminum window screen to cover these slots. There was evidently a lot of noise, ground noise leakage through these slots, even though these openings were out of phase with the pickup of the antenna feed. I still gained some signal noise improvement by putting a mesh over this. So this is what my system looks like. And then I had issues with RFI coming from the Cat5 extender, USB extender. And so I built this box running a 25-foot coax from the dish to this box. And then from here, I can run everything Cat5 or Cat7 back to the computer. And so I have the antenna outside, this on the porch, and my computer's inside about 50, 60 feet away. And this works really nice. And this hardware is identical to what I made for UCF. You can't see the electronics. No, you really can't see. If you're interested, I'll show you what it is. It's the RAS. It's the Tom Henderson. There's the LNA is on right on the feed, and then back on the mount is the cavity filter, second wideband amp, and then back through the coax to this box. And what I initially developed was this. This was I think an OM6AA had a site where they had information on a two-band 23 centimeter, 13 centimeter.
Oh, I've lost you.
Hey, Alex, you're breaking up.
Okay, so it's not me. I thought it was Elon again.
It could be.
Okay, so that's all 21 centimeter. I was actually with the Velop.
There you go.
Yeah.
Alex, you're on mute. Alex, you're on mute and you're breaking up a little bit on your video. And you just went off share. There you go.
Yeah, I have great internet service here. It went offline. So let's see. Let's go back to the share screen. Okay, so there's two options that will work with a small dish. Am I back on?
Yeah.
Yes.
Okay.
Yes.
The easy is the loop feed, and it's inexpensive. I think I have this list of parts in my video, but it's like what, maybe $20 worth of parts of slice up a cake pan, 5-inch diameter cake pan, and just make a loop. This works really well. I tossed around this design, and was really nice about this antenna is I can switch feeds on this in like 2 minutes. So I've been able to do incremental 1 centimeter steps in spacing, change the feeds in and out before any kind of environmental conditions change. And it was kind of a toss up between this, the loop, and I came up with this circular patch feed. And this one's a little more complex to make, and I basically found there's no difference between the two. But my final design that I've been using now was the patch feed, but it's a toss-up. So I would say if you want to have a tuned feed for 1.42 gig, this is a nice design. It's easy to make, get a feed through, just cut a notch out in it that you can gain access to the center pin. Solder it up.
And I'd like to give you a brief intro.
Oh wait, what happened? That's probably me.
Lost it again.
I didn't understand that.
No, I think
I can see. Yeah, I can definitely see how that works. So you're working around the hydrogen line. Do you have anything for the lower frequencies? That one of the ones that does interest me because of the Velop pulsar is in that 400 megahertz range.
No, this is one frequency. I mean, it's bad enough to get one optimized. And let's see. This is what the system looks like for UCF that I put together. And this was another problem in that the initial feed used the loop, and there was a cell phone tower nearby. And so it was a big 2 or 3 week effort to identify what the problem was and to come up with a completely different feed that the Cantana provides a low pass filter, and it filtered out the cell phone frequency, which was causing blocking and saturation in the LNA. But this is another level of effort to do to drill all these holes, to do match drilling on all these holes. I wouldn't recommend that unless you actually have to. And to finish it up, this is what I started doing over the past few weeks, is to do a 10-hour drift scan. This is through around RA 20 hours. And so it's like 16 hours to RA 16 to O2 in the morning. And this is a 45, 40, 35, 30, and I've got a few others. It's interesting to see how these are VSLR corrected scans, slices through the Milky Way, and getting some interesting feature changes. So I'm hoping to go through a larger slice of the Milky Way with this. That's my story.
Hey, Alex,
Okay, so
what was very
just
interesting
one last
was,
question.
oh, go ahead.
Yeah, one question, that the feed horns that you've actually made for your antenna there, did you get those from I think it was the American radio handbook? And I've seen a little bit of software for it. I was just wondering how you actually designed the dimensions of it.
Okay.
Yeah, that one, but also the feed horn. I do like that one for sure. That's great. It's nice and small.
The loop
but I
came
haven't
off.
tried.
If you look up OM6AA, I think the guy is in Norway, somewhere in Europe. He had dimensions for this, but this is a lot of lathe machining. This was a big deal to make, and so I came up with the idea of using a cake pan. So this is the Alex Pettit version of that, and it works just as well, and it is a lot easier to fabricate. The only key on this, and it's not obvious, is that this is covered with an aluminum gray hard coat, which is insulated. You have to clean it off for this feed through, or you get some really strange, poor performing results. And it took me a while to figure that out. So it looks like it's bare aluminum. It's not. And I think I found this online. I also did some actually testing and analysis, actually tested this, but I found online a square patch and a site that allows you to find out the dimensions for a round, but it's like 103 millimeters. So I can send this to you, but toss up, I would try this one because it's so simple.
That's good. So you've got those on your page somewhere?
If you look, if you look up QRZ.com, the ham radio website, KK4VB, I have this on there.
Okay. Is it QR what, sorry?
QRZ.com. That's a ham radio page, and just look up my call sign, KK4VB.
Okay,
Alex,
great, thanks.
Alex, this is Richard. I assume this feed is optimized for some F to D ratio on the dish. Do you have any thoughts on
that? Let's see, it works for about 0.35. I played with the depth on that. What I did on the scope in the box, let me go back to this one more time. I don't know if I can figure out how to share. I did some pretty radical changes to the scope in a box, in that I was getting a lot of ground noise, because the scope in a box, this is an F to D of 0.35, but the sides are like 0.6. There is lots of over illumination on the sides. You get lots of ground noise pickup. So I actually went, this long dimension follows the parabolic shape of the dish. These were like at 45 degrees. These are just basically shields. But the dish is about 0.3, 0.27 or something like that. So that this
You're
grid.
not sharing.
Let's see. Well, I don't know if it matters anymore.
Okay.
I'm lost. Let's see. But the dimensions should work with a 0.35. Whoops. Let's see. I'm back. Should work with about 0.35.
Okay.
Thanks.
Alex, one other thing that I thought fascinating about what you were doing is when you showed the stellarium, why you're getting that shape on your picture, and you had the stellarium versus your the Milky Way, and why that the shape of the signal looks the way it does.
Oh, let me see if I can find that slide. The
Because
slide.
I didn't realize until you did that, I didn't realize why I was getting the shape, the signal, the way it is until you showed me the stellarium view.
Let me see. Maybe try this one more time. I'm hogging up, taking too much of your time. Let's try this. This?
Well, yeah, but you had the stellarium, and you were showing how the when you do a drift scan, it actually goes up, it goes across, and then it goes up almost parallel to the Milky Way.
Oh.
And that,
I don't know where that is right now. Yes. If you get too far high in the declination, you're slicing through the Milky Way at a 60-degree angle just because of the rotation of the Earth versus the axis of the Milky Way, and so you don't get clean slices. I'll see if I can find that. If I can find it, I'll come back. I'll disconnect right now.
Great, because it explains why the signal looks the way it does, and which was fascinating, and using stellarium. Okay, Alex, thank you.
I have a question, Alex, if I may.
Sure.
What integration time are you using for your data?
Repeat the question.
What integration time are you using?
5 minutes.
Oh, per sample?
I'm running, it's like 870,000 samples. The SDR samples like about 3,000 samples a second, and I've been integrating for five minutes.
Okay.
Okay. All right. Any more questions for Alex? All right. Archer, did you have a system that you want to show or ask questions, get some updates to? Well, maybe we lost him. Let's see. Charles, you want to show off your system?
Let's see. That might not be too easy at the moment.
And by the way, heads up, everybody, I'm going to ask all of you guys to show off your system, so prep now.
Let's see here.
While you're doing that, let me get Paul online. Paul, you got any, thanks for putting this group together.
Much better. Right, I couldn't find the unmute button. Sorry about late arrival. I had I was on another Zoom with my university friends in the UK, and we got into some interesting engineering questions about battery technology. I've no further progress at this point in this area. Nothing to show you, Rich. So I'll see if I can dig around and find something. But someone else maybe have something.
Okay. Well, thanks, Paul. I'm saying you're sort of the co-host here, and so feel free to jump in with questions and or direct. You know these guys better than I do. All right. Charles, you got anything yet, or do you want me to go to the next person?
I'll let Paul have some time. He hasn't He hasn't been in here with us that long.
All right. Well, okay, let me go to Andrew. Andrew, what kind of system do you got? And what do you think about upgrading?
Sure. Yeah. So let's see. Hopefully you'll be able to see the screen here. So here's a little bit of display on my system at the moment. As I mentioned, I'm interested in low frequency radio astronomy, but I guess geophysical monitoring in general. And I bought myself a moderate end NUC just over Christmas, and I've been getting a few things going on that. So just showing you a few things here. So on the left-hand side, I'm monitoring 15 megahertz WWV, WWVH with a GPS-locked receiver. So I'm interested in phase anomalies and frequency anomalies of that signal. And solar flares produce effects from time to time. And so at the top here, I've got a Dopplergram. This is about 20 hertz wide. I'm using an AirSpy SDR with a SpyVerter, both are GPS locked. I bought myself one of those Leo Bodnar frequency standards, which is really good. The bottom plot here shows the last few hours. The top one here is essentially the frequency change. So there's ionospheric conditions that perturb the frequency over the night. This blue trace here is actually the amplitude, and this blue one here is the 14.996 megahertz or thereabouts, which is the Russian RDL station. So I was kind of interested to see if that would pop up in the bottom trace as a noise trace. So I'm kind of monitoring, high frequency time standards. Just I'm interested in just seeing what the ionosphere is doing, essentially. Over on the right-hand side, I also do meteor scatter, and that's something that Paul and I have been discussing over a while. It's tricky now, now that analog TV stations are gone. Finding a distant transmitter to do some forward or backscatter meteor detection from is difficult. I'm monitoring a station in northern Tasmania and getting some meteor counts, and so that's essentially coming from a SDR play SDR with a Yagi. This is at around 50 megahertz. And the bottom plot, I am using this colorgram software on the RMOB group, and my data goes up onto the RMOB site. This is Radio Meteor Observation Group, and you can look them up. And this is a summary over the last month, and seeing some diurnal variation, which is always a good sign. One of the things that we all suffer from are interference sources. So I've got I've got a birdie in the background here, and I've actually probably got a little bit of the ground wave from the distant transmitter coming through occasionally. But I'm seeing things that look like meteor counts, and I'm also affected by aircraft as well. Flights going between New Zealand and Western Australia fly over us, and I see those quite regularly. So that's some stuff happening in the background there. I'll just close down a couple of windows here. So there's my AirSpy system running on 15 megahertz. I've got some sort of artifact here, which is possibly even an FM transmitter beating down. But generally, my spectrum's reasonably clean. I do have a few sources locally. Our TV set's sort of one of them. I'm trying to do some intensive observations, so we're not watching TV, that's for sure. Yesterday afternoon, I was trying to see some Jovian bursts. So this is a grab from some recordings I made yesterday. So I was using, again, the AirSpy system, taking 8 megahertz chunk with radio size spectrograph. And so this is sort of yesterday afternoon local time, and some type 3 solar bursts coming through quite nicely in this bottom plot here. Radio sondes going off, drifting through. I haven't actually had a good look through this to see if I could see any Jovian bursts, but of course, it's not really favourable at the moment. Jupiter was crossing the meridian late in our afternoon, but the sun was still up, and so the ionospheric critical frequencies are quite important. I might expect to see something sort of around 22 or so megahertz, but I'm using this free cam software, which you can just record a movie of your screens, and so I'll go through that later on and have a bit of a look. Another thing I do is VLF. This is a kind of a crazy plot here in the background, but I set myself up to measure phase and amplitude of VLF stations, and I'm using Spectrum Lab with a GPS phase-locked sound card, essentially. Complicated plots here. The top one is this one here, this dark brown. That's the signal strength of the Northwest Cape transmitter in Western Australia. And you'll see occasionally small enhancements due to solar flares. So these are some enhancement of signal. Nothing much yesterday. This bottom plot, though, this is the phase of Northwest Cape, and it's not the best example I could show you, but yesterday, around 0 UT, it looks like they've changed the frequency of the Northwest Cape transmitter. Normally, it's about 10.8 kilohertz, but it has been known to shift by a few millihertz, and that really upsets my phase measurements. And I put this phase drift, so I'll go away later and try and calculate the frequency offset, which prior to this time here at least was about 130 millihertz or so, and I suspect it's probably shifted again. Not sure why they do that. Probably some sort of Rich, you might know something about that. But that's the other thing I do is VLF. Just finally, I do have one other little thing here. This plot here, this is again the Doppler plot from the WWV-WVH measurements, and here's an example of a sudden frequency deviation due to a solar flare. Only a few hertz, but these stand out quite well and are a good way of looking for extreme ultraviolet flashes from the sun. So that's me, and hopefully I'll be able to unshare the screen if I find the right combination.
And go to the top of the screen, yeah.
Yeah, that'll press the top of the screen. We'll get there eventually. Sorry, folks, for holding up.
That's fine. Yeah, go to the top of the screen. It says,
it's now,
yeah, there you go.
It's now appeared. Great.
Excellent. That's really good.
Yeah, I'd encourage getting a good quality NUC. The one I've got, I'm quite impressed with, and I can run all those screens there. I've actually got 4 SDRs running on that without any sampling problems. So, yeah, if you can spend, I think this one cost me $800 Australian. So, yeah, well worth it.
Andrew, this is Richard. I wonder if you saw any changes in your WWV Doppler plots with that volcanic eruption in Tonga, I believe it was, or any tsunami activity.
Yeah, look, unfortunately, Richard, I was just getting my frequency measurement sorted out pretty much on that day. I do have a bit of a recording, but I didn't see anything, and I would have loved to have had a nice example there. I did see some interesting things with the VLF phase measurements, which I'm writing up as a publication at the moment. That certainly showed some interesting effects, but yeah, unfortunately not with WWV.
What kind of antenna are you using for your Jove system?
Yeah, I'm trying. I've had dipoles here. I've had the Radio Jove type dipole system. I'm on a rural block, and my trees like to drop the occasional branch. It's not good for dipole antennas. So I'm trying out at the moment a loop antenna. It's pretty good for the sun. it's a 1 meter diameter loop with a very low noise broadband preamplifier. And that works nicely for the sun. And I'm hoping that I'll see some Jupiter bursts with that. Polarization, I'm still working out, and also its directivity seems to be pretty broad in the horizontal and vertical plane. So, yeah, stand by for confirmation. But I might have to wait till the next Jupiter season when it's better placed in the night for these sort of measurements, and also less interference from the folks around me.
That's great. I hope that works out. I've tried using a Wellbrook loop here in Honolulu, but my background temperature is about 3 megakelvin. So it's not, I can't even see the sun with it, but I hope that works, because a lot of folks are having trouble squeezing those dipoles into their tiny backyards.
Yeah, that's the motivation, Rich. Yeah, look, and the loop's much better for the common mode noise too. So yeah, we'll keep working on that.
Great, good luck with that.
Thanks.
So Richard, the one place, if you're interested in correlating the tsunamis and the volcanoes with the basically the SID data, you go to the Stanford website and look up the historical super SID data, and just look for the dates. They'll have all a couple hundred super SID sites, and you could just view that date and see if there's any correlation with the with any natural event.
Okay, so, great, Rich.
Yeah, that'd be a place to go. Thanks. I've asked that question many times too, especially when I think Tsunanga, what was that big volcano just blasted, and I tried that too, and I didn't see anything. But and I tried it with the Japanese tsunami too, and I didn't see anything. So theoretically, the volcano or the activity of the crust moving would change the ionosphere, which would cause this thing to show up. But that's a theory, but I don't think we're not probably not sensitive enough with the super SID stuff to see it, because I haven't seen it, but we've been looking for it.
Two things I could comment there very quickly. So I was measuring the phase and amplitude of Northwest Cape, and I can definitely see the effect of the atmospheric waves on the ionosphere. That's quite clear. The other interesting one is there was an awful lot of lightning at the time, and I reckon I can see modulation of the number of spherics produced in the cloud that probably relate to atmospheric waves internally generated in that plume. So that's another thing. I'll see if the reviewers like that one. But yeah, by doing some Fourier analysis of I've got 2 second amplitude and phase data, I can see some of those things.
One other fun project to do, which I actually captured in it was 2017 eclipse up here. The eclipse passed right between my station and the transmitter, and I was able to see a nice bump when the eclipse went by. So if you guys got eclipses and they're anywhere near where your transmitter receiver is, mine was right in between. I'm not sure if that's required, but it made a perfect, almost looked like a flare, but it was a sort of a symmetric flare. And so that's another good one to look up historically. If you have any eclipses that you've had, look up the eclipse date and see if you see a flare where that date was. And that might be the eclipse itself instead of a flare. Really fun. That was a fun project.
The ham sci folks have done some of that, and that's how I kind of got interested just more recently in those frequency measurements. I've done quite a bit with eclipses, so yeah.
Yeah. Okay. Excellent. Let's see. Blair?
Yeah. Talking about the Tongan event, I'll just share this with you guys. This one. So as part of our seismic stuff, we do, I do high resolution barometric pressure. This is the 24 hours daily record, and you can clearly see the event coming through. Here's a zoomed in one of the event. We're looking at, in South Australia, about 4 millibars from there to there. Really nice land waves coming through. So yeah, 1 hertz resolution and 24-bit. So very happy with that one. Now I need to get out of that. Just hang on a sec. Close that. Stop share. It's probably easy to do that one. And I'll show you this one. Okay, so where are we? Do that again. That's my imaging setup we were talking about earlier. All the red stuff is ZWO. So optical, not interested. This is my dish. It's it will track. There's a better picture of it probably. So it's old house mounted. There's the large segment here that you can see is the half circle for the drive. So it's got a tooth belt around it, and it just goes around a stepper motor with a gearbox on it. Same with the bottom. There's a large one. You can just see it around here. There's a tooth belt around there, which just goes via I think it's a G2 for anyone that does 3D printing. They'll know what that is. I joined it just by cutting a diagonal across and pushing stainless steel pins through it. Hard exercise joining belts. But anyway, that worked fine. And that's what I built. Not interested in that. So I was doing 2 polarizations on and summing them for 1420, but I've been too busy doing other stuff for the last couple of years, but I've got to get back onto it. But it's got a PIC that does the drive originally, and now it's got an Arduino Uno that drives all the stepper motors, and the receiver can be basically tuned to any frequency I want. The feed horn obviously is 1420. Yeah, so that's what I've done. Really can't show much more. But that was, I got really enthusiastic about 4 years ago, and that's how far I got, and I really need to get back into it.
Beautiful.
Rich, Rich, I do have something on the screen. Where's Rich gone? Yeah. Relating to Andrew's setup there. You want to have a look?
Go for it.
If I share screen 2. So you're getting that share. You can see the Argo. That's live. But you can see the problem I have is that just the local interference. So I'm actually monitoring the same radio amateur beacon as Andrew is. I think, Andrew, you're on VK7RAE on 50 megs, 50057.
Yep. That's right.
Yeah. Andrew's to the south in Hobart. I'm to the north in Melbourne. But the horizontal line, that's just local interference, that's fine. It should be coming out around about 800 because I'm on CW with an 800 tone. But all this crap just comes in on top, so I can't do reliable counts. But sometimes I get something like that, which is, you know, when the interference is not there. So it's intermittent interference. And there is a superb trace. I can't remember how long it is. It's at least 30 seconds or more long. Yeah, exactly the same setup. So that's a while back, and that's today live. So The issue is the interference. I don't know how to deal with that yet, because I'm not on a rural site. I'm right in the middle of Melbourne. If anybody's got any ideas about how to get rid of that interference, it'd be really good.
Actually, one comment I can have there, well, at the moment I'm using the Yagi, but I have used the loop antenna. My preamp still got gain at 50, and that's pretty good as well. I've gone to the Yagi. Yagi's got a little bit more gain, but you could try a loop maybe.
So that 1 meter loop on 50 megs is doing it. Yeah, that's interesting. I had thought about trying a loop. I think that might do something better. I do have a Wellbrook loop, which may do the job, but I suspect that the built-in preamplifier is up the creek on the Wellbrook loop. I need to get a new preamp for it. I'm not getting very good signals out of it, so I think I transmitted once and zapped it. Fortunately.
Do you know where that garbage is coming from? Do you know where that interference is coming from?
No. If I knew, I mean, some of it's LEDs.
This is a tiny spectrum analyzer. Here in the States, they sell them for like $60 US. And this will help you pinpoint any type of interference from lamps or anything else. And you'll be able to see exactly where it's coming from. It's called the Tiny Spectrum Analyzer. If you go to eBay or Amazon, and what it does, I don't know if you can see that. It tells you, you can select the range. If you see a peak, you can select that range and you can start moving it around, and you'll be able to pinpoint. The only caveat that I think this only goes to 900 gigahertz. No, I'm not sure about that.
Megahertz.
Megahertz, yeah, not gigahertz, yeah. So this may help you pinpoint where the interference is coming from, and you should be able to, if you pinpoint it, you'll be able to fix it.
It's intermittent, that's the trouble. So it's obviously something that's getting turned on and off. I mean, you can see on that one with the long trace, the background is black, so there's virtually no interference there at all. I don't know whether it might be common mode in the cable, whether ferrites would make a difference there. Andrew's nodding, so there's obviously something in.
Yeah, put ferrites in everything.
Yes.
Give it a go. Yeah, no, that little spectrum analyzer is a good thing. I've got something similar, and an AM radio I find also pretty useful. Just tune it off a station.
Also, could it be computer generated? And do you have ferrites in all the cables?
Well, that's what I'm saying, Pablo. The ferrites, I think, might be the key. I just I had to replace the cable recently. I chopped it while I was chopping down the greenery. I chopped the cable as well. Common problem. So I've got it's probably not a very high quality cable that I put in there just to sort of get the link back. But I might try rerouting the cable so it's not actually going past my LEDs. I mean, my LEDs are off at the moment. I'm still getting that interference. So it's coming from somewhere else.
The other folks, yeah. The other thing too I found is that even though FM is above your frequency, like you still get subharmonics of FM. So I've got a couple I've identified, definitely FM, like half the frequency, not a harmonic. So they're getting into things and intermodulation products essentially.
All right. One other meteor kind of a thing going on is Jay Wilson, our vice president, came up with a potential approach that maybe SARA sponsors some 50 megahertz beacons for meteor. And we would get a couple around the Earth, and obviously we'd want one in Australia too, that would allow sort of supplement the loss of the analog signals. So anybody's interested in that, he's got a design for the beacon. It'll be on ham radio bands, and it'll be an official beacon. So, which would theoretically be legal. My guess is he's checked into it. It would be legal as for ARL. Yep. So anyway, yeah, let me know if anybody's interested in that. Maybe we can get a group together, and we probably, SARA could probably fund the equipment to get the beacon going, and maybe even help supplement power funding.
I would be very interested to follow that, Rich. There's a group in the UK doing exactly that. They've set up a beacon in the Midlands, and now they're looking for ground stations within the UK. And my plan here is to raise that with the the Astronomical Society of Victoria, because we could put a beacon into our dark sky site. It's a quiet area, but it's power. It's 24-hour-a-day power, and there's internet there. And that's a pretty good location. It's north of Melbourne, but it would be a good location in terms of the radius around it. That's something I'm pursuing at the moment. So I'll be very interested to get some details, Rich.
Yeah, that's a pretty good thing, because a lot of the amateur beacons, the problem with them is they're transmitting digital modes these days, so that they're fairly broad spectrum, and their duty cycle isn't 100%. So if you had a nice, continuous narrow band GPS locked transmitter, you could do a lot of interesting things like, Doppler measurements, just aside from counts as well. So I'd be happy to help out there.
Yeah.
All right.
Well, I'd like to pursue that via email, Rich, and we'll see what we can do.
Sounds good. Sounds like a good worldwide project to do.
Yeah.
All right. Charles, do you got you found your stuff yet, or do you want me to go on?
I found a picture to let's see if I can share it. All right.
And by the way, Charles is our SARA historian. So if anybody is interested in any of the past history, he's got a ton of files.
Well, I don't see it come up in my choices here. I definitely don't want that one. All right, it's here we go. Let's try this one. Okay, are we seeing my dish?
Yes.
Okay. All right, that's my 3.7 meter, and it's got a Mike Mellum, kind of a copy of the OK1 DFC, I think it is septum polarized type feed. So it's got it's made for 1296 transmit receive, but still works very well at 1420. So I've got two polarizations out of that. Basically, you can kind of see the little there's a little plastic bag on the left side of the feed. That's where I've got the LNA at, and it's one of the SAW type filtered LNAs, and then that goes through coax into the house where I've got the RTL SDR and SDR sharp type receiver set up on the computer here, and the scalar ring on that's a cake pan type scalar ring that's fit over the square aluminum box that's the waveguide for the feed. And then the little dish on the right is something I'm working on for 8.4 gigahertz deep space network amateur stuff. I'm actually trying to switch that around to where it's polar mounted so that I can track Mars for a period of time. Declination doesn't change enough that I have to move it during the day. Let's see. Any questions on that dish? And I'm only moving it in declination. It's right there we're doing the sun transit, and so it was just set on fixed declination, and I was kind of verifying that the sun was coming through at the right time to make sure I was actually on due south, and the declination was lining up with the sun correctly. So that worked out pretty well.
What receiver are you using for your 8.4 gigahertz antenna?
It's homemade. It's pretty much made from a 8 gigahertz phase locked oscillator, mixing down to 400 to 450 megahertz type range. So that way, if you're looking for a deep space network signal at 8.440, say, it would be at 440 megahertz on a receiver on the IF. And of course, it's phase locked, the GPS, 10 megahertz. And I've got feeds, similar kind of feeds for satellite type use that I was doing with military stuff, which is in that same range. Let's see if I can bring up there we go. All right, are you seeing hydrogen type scans there?
We still got your antenna up.
Still the dish. Okay, so it's not sharing that screen.
You got to unshare the one screen and reshare the new one.
Okay.
Okay, you're unshared.
Okay, about that.
Yep.
That's good.
All right, so those are some of my drift scans captured at certain points. So you can see nice resolution on the different peaks as you're going through. This was at minus 15 declination, and let's see, galactic latitude 2.88 negative degrees, pretty close to the on the crossing of the galaxy, and it's at 228 degrees galactic longitude. So I get a lot of pretty nice, interesting peaks out of that, as far as seeing a number of different spiral arms and things. Let's see if I can find another. I mean, there's a lot of them that are more interesting once they pass through, as they're passing, to see the different peaks come up and down. And of course, actually, it's more interesting when you're not looking toward the center of the galaxy, because you got so much velocity confusion in that area that it actually just looks like a big lump. So I find it's better to be 20 or 30 degrees away from galactic center, and you get a lot more interesting peaks and sharp definition of the velocities in that. Let's see. And I doubt I can bring it up, but I do have a seismometer online that, since you're talking about seismometers, it's fairly worthless here because all I see is traffic. And so it has to be a pretty strong, let's say magnitude 5 or something, within 1,000 miles, and preferably at night when it's much quieter, because I'll see every truck that goes by on the road in front of the house here. So once you know what a seismic event looks like, it sort of stands out, but traffic is definitely similar. So I can kind of look at the screen and say nothing obvious in that screen in just a matter of seconds, but I don't think I can bring that up very easily. Let's see. All right, let's see if you're still seeing the hydrogen line stuff?
Right.
Okay. All right, let me stop sharing on that and see if I can share the seismometer screen. Okay. About that.
There it goes.
Okay.
Yep.
So it's a Raspberry Shake. So the Raspberry Pi with the seismometer sensor hooked up to it through an interface board. So this is kind of what I get out of that. I mean, I can tell all kinds of interesting things like the duty cycle on my heat pump for the house. You know, if my wife is doing the wash or whatever, you'll get plenty of seismic contamination out of that. But most of the peaks that I see on this screen, for instance, are just traffic. Helicopter going over or something like that will show up. And they even have a version of this for infrasonic. So they do have a sensor to input this into the Raspberry Shake at infrasonic to look for you know, subsonic events or things like that volcano that went off. Okay, now that's about any questions on that. I mean, I imagine everybody's seen the Raspberry Shake. I've got a better one, a much better seismic sensor that I used years ago, but it's way outdated software-wise, so I can't. I mean, the computers that will bring it up are Windows 98. And they record the data and work pretty well, but it's not, I don't have software for the bigger sensor that is much more sensitive. That one, I did pick up the Indonesian quake back in, what was it, 2004, where we had that tsunami in Indonesia. So I was able to pick it up with that one and see the ring down on the earth for a couple of hours. But that one's a Windows 98 type platform of software and hardware. So I'm kind of stuck behind on that one. So I just went to Raspberry Pi because this one is easier to work with. Okay.
Charles, is there something there that'll alarm you if it goes over a certain level, or any way to review old data for that kind of stuff?
Actually, there is on the old system. In other words, the Windows 98 version would capture events and record them to a separate file. But the newer stuff, I'm not as aware of how they're capturing any kind of events and things on the Raspberry Shake. It's not as obvious unless it makes the news and you go back and look at the data. So I can look back about a week. And of course, some of this gets streamed to the internet. And so they'll have thousands of people, and mostly in schools. This is popular with schools, but I can't imagine a worse place for a seismometer than an elementary school. 1,000 kids stomping around. It's got to be quite noisy. But of course, at night, then you you probably would have a good, clean recording area for something like that in a school. But
yeah, they did that in Australia. The ANU went and put a bunch of precision seismometers in schools, and it was just such a waste of instrumentation. It was just silly. This is the network that I look after. This is an hour ago in South Australia, so you can see a rather nice event going through there.
Yeah.
The time delays and all that sort of stuff. So we have nearly 30 instruments in South Oz that they're all in really good quality rock sites, which is why I've got no time to do radio astronomy.
Once that wasn't me.
Not me either.
So in the spirit of multi-messenger astronomy, I was wondering maybe we get one of our software guys. I'm just formulating an idea to combine the super SID data with maybe magnetometer and the seismic data, and then be able to trigger if we get one or two of them triggering at the same time. And that even Radio Jove would be good to plug into that. So just a thought that, because I think people are doing a lot of work with the software now, and we might be able to capture all this stuff and combine it. And then put all sorts of alarms and whistles in it.
Yeah, we run a very good triaxial magnetometer in our seismic vault. We've not seen any correlation between large earthquakes and that. But we don't get large earthquakes in Australia. Well, not very large ones. Certainly we don't get large local ones. But yeah, we've got a Magson, which is a very nice piece of kit. We don't see anything. We certainly see all of the changes in the Earth's magnetic field from CMEs hitting us, but they're fairly easy to pick up.
Okay. One other thing to bring up is, and I think Alex and Pablo, you probably most of the hydrogen data. Getting some of the our Australia folk to get some hydrogen data from the Southern Hemisphere for you, because we got a big hole in our Northern Hemisphere hydrogen data. And if they did, how would they do it? How would they get it to you, and how would they collect it? What do you need?
I think I'm too early to handle any other data, but I mean, it's just frequency text, a column of data. But I need to give me a few more months to work with my software. I've got some issues integrating the VSLR correction and making it efficient. Everything works, but I wrote it a year ago, hadn't used it for 10 months, and so it's taken a little bit of time to get back up to speed. So it has a few more iterations, refinement iterations. It might be that Pablo and Ted's software might be more open to might be up to speed more than mine.
Okay.
Well, first of all, I'd like to take credit for what I do. And this is not what I do. This is Ted Klein's bailiwick. And I'm only a user and a guinea pig for him. So let's make that clear. But I think his program would be perfect because he also has software to translate any type of data into the EZRA, which is able to plot up to 70 plots, including the whole sky plot from any kind of data, as long as you translate it into his language. And he already has that. So the person to talk to, for sure, is Ted Klein, and he already has the software. So it would be for him very easy to do.
So who from Australia would like to help I'll hook you up with Ted Klein probably next month. And if you want to collect some hydrogen data, and of course we'll share our hydrogen, Northern Hemisphere hydrogen data with you guys. And but we need some Southern Hemisphere hydrogen data. And who would like to be the guinea pig?
Rich, on that, I've got on my other screen now a report from work that was done from our dark sky site, the Astronomical Society of Victoria. It's not my work, but Steve Bentley, who did it, I hope will be with us next month for the 3 monthly one. But I'll just put it on the screen just so you know where it's heading, and see whether this is the sort of thing you're looking for. If I share that screen, you can see neutral hydrogen survey near Galactic Centre. This is the 8-meter dish north of Melbourne. Just zoom in a bit. So Steve Bentley was running this with Graham and Tim, and there they are. Actually, in there, it's a shipping container with all the equipment inside it. Very nice Faraday cage. And they're using K-stars to direct the dish, and they put a grid onto the computer screen with the key, so Sagittarius, Scorpius, and Telescopium, and then they take a reading, and then they're basically doing it 1 pixel at a time. So they're moving, scanning essentially, but they're having to do it manually. So there's the raw data, and then they're ending up with these sorts of plots. Now, I can't interpret that for you. Steve will have to do that because he was the one driving it, but you can see that there is some real data coming in. It's being analyzed, color coordinated, and then producing this. So this is the Galactic Center over on the left, Telescopium over here, and Sagittarius down here. And there's another Photoshop version of it with K-stars in the background showing the constellations. And then there's discussion in there. So I'll get Steve's permission to circulate that document, perhaps. I can't do it now, but it's his document. But perhaps if we circulate it beforehand, people can have a look, and then encourage Steve to come along next time. He may be able to then suggest what data could come from this end to be used by and analysed by people at your end. Is that the sort of right direction we're going? On mute, Rich.
Sorry. Yeah, and tell him we can share all the Northern Hemisphere data he'd ever want with him too. And he can combine that, because it looks like that gradient. I don't know, Pablo, is that gradient plot in the one of the plots? That looks new. Is that one of the ones that you and Ted or Ted's come up with?
I believe so. Yeah.
Okay.
He's got so many plots. It's hard to keep track. I mean, he's done a fantastic job. I mean, it turns the scope of the box into a real scientific instrument.
Okay. All right. Well, we can absolutely share the data with everybody, and then we'll see if we can get some Southern Hemisphere data from you guys, and you guys get our Northern Hemisphere data, and we're gonna have a really good setup.
Yeah.
Okay.
It'd be nice to have a site where you could actually kind of put all the stuff together in real time, wouldn't it? The Radio Meteor folks do that. Solar meteor counts go online. You can see a map of the sky. But yeah, it'd be really nice to see that with the neutral hydrogen.
Well, let's see. I don't know who can address that. Pablo, is there or Pablo or Alex, is there a way we can do that? Well, the problem is that you're only looking at one declination at a time for 24 hours, and so I've had my Spectre. I have a Spectre Cyber and I was doing that for a while. So you basically have to tell them where you're pointing in declination, and then assume you're doing meridian transits. Anyway, okay, yeah, but that's still possible. I think that'd be a great feed to have. All right, where was I going with that? Okay, any other questions? Duncan, you got any projects going on that you want to show off?
Yeah, I do. So I'm going to share my screen, and I'll just flick through a few things I've been working on. Have you got that? Hello?
Yeah.
Yep, we can see the scope.
Yes.
Yep. Okay, well, that's my first attempt on a VLF looking at Northwest Cape. But there are other VLF transmitters floating around at this site, as seen from this site. So that's going reasonably well, and I'm moving towards getting some data about that. Its variation in time. Flick on. This is something I worked on professionally, but I've now stopped, but I still use them, and I develop variations. This is called a four-leaf clover. Well, it's actually a four-square one, this one. This is a dual polarization antenna made out of PCB, and it's matched to 50 ohms. The actual LNA sits on the other side of the base plate. There's a current version being developed where it actually sits on the base plate, so there's no connector. So this is gives you two polarizations, two linear polarizations. So the top part is FR4, and what you can't see, well, where the support structure is, which is obscured, but it's in the central area. That's all made out of some low loss PCB, and it's made into a little box or a rectangular void, much along the sides of paper cutouts used to make as a child and put tabs through. It makes quite a stiff structure. And this is a shield. Just have a look at some of the, gets rid of some of the ground stuff. So that's going up on my 6 meter sometime. At the moment, I'm actually working on the LNA at the back to put in a calibrated noise source to get some rigor into what I've been doing. So I can actually determine something about it. This is a development one here. This one here is actually made out of aluminium plate. It's an antenna that I can get reasonably good bandpass from 800 to 1600 megahertz. Reasonably good is defined as being better than 10 dB return loss. And there's a comment earlier in the thing about return losses and matching. You just have to be a little bit careful, not so bad on parabolic dishes, but on cylindrical antennas, which is what I worked on. Standing waves can form between the vertex and the focal plane, and this can cause interference. And so you find that as you scan across the band, you'll get modulation of constructive and destructive interference. So anyway, so that's a little one I'm still working on. That's that was just the quick lash up to get an idea what was possible and to have a fairly simple geometric shape. This sort of antenna is actually used on Chime, not this particular one, but Chime has a four-leaf clover antenna that I played around with many years ago with another collaborator, Mei-Ling, and they built a whole lot of those antennas. They're reasonably, when they're in the PCB form, they're easy to fabricate and replicate. So And then that's basically what I'm working on at the moment. That got lifted lifted up a couple of weeks ago from its resting place when I was doing transit stuff, and it won't be usable for 3 or 4 months because it needs to be counterweighted and have its control systems verified. So it's a 6 meter. It's f.3, 0.3 F/d, and yeah. So what was I going to say? Yes, that's actually an antenna that's made the transition from being a fixed instrument for satellite work, fixed angle, fixed azimuth. I put a tractor trailer bearing for the AS, and it's basically just a couple of car hubs up on for the elevation tilt, and they've been extended a little bit, so it's in a transformation between a fixed antenna and a tracking antenna. And I also play a little bit with satellites, and I got distracted, but I went off and did a little challenge, which was to try and make tracking satellite antenna for my daughter's school kids, so they can see that out of the scrapyard you can actually make things. And so what I've been working on is a asrotator which is made out of an opal disc brake and integrated bearing, and that's the asrotator. And then that's driven by a tooth belt, which neatly fits into the disc brake. And I turned up a small pulley, and that's linked to a Toyota windscreen wiper motor. So I'll talk about that a bit more next time. But so that allows UNOs and basically cheap magnetic sensors and accelerometers to be used to give you the lock loops, control loops, and point it where you want to point it. So that was basically to look at satellite and teach kids about Doppler shift. So anyway, that's my property in South Australia. Sorry about the noise. My pager just went off. Yep, I think I'll at that point I'll stop. Anybody have any comments?
So that's
excellent stuff.
Axle, it's a car axle for the elevation.
Yeah.
Did you use the brakes to lock it in place?
No, I didn't use the brake calipers. It was something that crossed my mind. This uses a lead screw. You can't see the lead screw at the moment. It's not up there. So it's actually effectively locked at 3 points. It depends on the lead screw. And this actual dish will go bottom heavy. So there'll always be a down force on the lead screw. And if anything fails, it'll go down to that vertical position. So yeah, that's a good suggestion about the discs. Yeah, on the other, that it's a sequence of thinking about things, and I hadn't thought about the discs till. Well, long story is, my son-in-law turned up with a trailer with what he said was scrap. I looked in this trailer and saw the opal front wheel bearings and disc assemblies, and that was well after I'd welded up all this stuff. So it would have been a good addition.
All right. Any other questions? Okay, that's great stuff.
Thank you.
All right. Last but not least, we got 6 minutes, Preston.
Well, I'm on my wife's computer tonight, and I'm not on mine, so I don't have any of my data and stuff available. So someone else is going to need to fill the 6 minutes.
Okay, not a problem. Okay. Anybody else got anything they they want to bring up? All right, so let me give a little sales pitch here. We do have a SARA journal, and what I like to do is get observation reports and small articles, through 3 to 5 pages if you want. We'll publish them in the journal. It comes out end of February, every 2 months, basically starting in the end of February. Let me know if you want to give in an observation report. It's like 1 page. What's the system that you got, and what did you actually observe? And we can do anything from magnetometers to supersids to radio jove to hydrogen pulsars, FRBs, whatever you guys got. Just a quick 1 pager. That'd be wonderful. And that it's just to give the amateurs a chance to start publishing and just to show off some of the stuff. And I'm saying, if you join SARA, it's $20 a year. Then you get all that for free. Also, I'd recommend if you want to log into the Western Conference, which is March 17th to 18th, that you go ahead and join SARA, and it's $15 for the online Western Conference, and you'll get the that for that $15 you get an online not the journal, but the proceedings too. So that's very, very good to do. I put links into the YouTube channel. If you have any questions about YouTube or that, we've got all sorts of presentations on YouTube. I'm going to post this on YouTube in the next couple of days. I'm going to do a little editing to get rid of some of the ums and ahs, usually me, and then I'll post it. So then you guys can review this. If you've got your email address on the chat, I'll probably take that off so because the rest of the world doesn't need to see your email address. But if you guys want to go and save the chat now, because it goes away when I log off, go ahead and save the chat, and it's in text, and remember where you saved it. That's the key on that. And then you guys can start talking to each other remotely with emails. Let me see. I'm saying the only thing is February 3rd, there's a British Astronomical Association YouTube at 1930 UTC, which is like a Friday. And so feel free to log into that. I think you need to get Paul Hearn's email, but that's on the forum. Also, join the forum. Go to the SARA website and go to forum, and then log in. The first time you log in, Tom Crowley will have to approve you. But once you get on, then you got unfettered access to the that. And there's all sorts of discussions going on about every kind of system you can think of, from FRBs to magnetometers to I think we got masers is the big one right now that's going on in the forum. All right. That's all I've got. This has been a great session. Thank you very much, everybody in the Southern Hemisphere. And I think we even got a Canada represented in the Northern Hemisphere. And so feel free to contact me at any time and, get links to anybody you want. All right. Any last comments?
Yeah, I'm just going to, please may I share my screen, and I'll show you what some Vela data looks like for the SNR of my system. If I can get there. Sorry, I've lost control of it. I'll save it for next time.
Absolutely.
We should have a bigger turnout from this end next time. It'll be the 3 monthly, which people are aiming for.
Not a problem. We had 17, I think, at the most this time, which is actually pretty good, and
that's very good.
Getting to know each other.
Yep. We need a few more from this end, so I'll drum up some business.
All right. Anybody else have any comments? All right, save your chat so you can get the links. And when I'll put the chat on the YouTube video, but I'm going to erase all the email addresses when I do that. So it'll just be the links to various other things. So, okay. All right, thanks everybody, and see you next same time next month.
Thank you.
Very good meeting. Thank you all.
All right.